Welcome everybody to Quadratics Functions and Equations Lesson 5. Before we get started, I just want to apologize. The neighbor kids are playing just outside my window, so you might hear some screaming or laughing or something. So today we are going to look at converting our equation from general form to standard form. We know that standard form offers us a lot more information about our parabola than general form does. So just a reminder that when I say general form, I mean our y is equal to ax squared plus bx plus c, and then the standard form is what we learned just recently, that a multiplied by x minus p squared plus q. So we are looking at going from that form into that form there. And we are going to do this by a process called completing the square. It's a little bit weird, but once you get the hang of it, it's pretty nice. So if it'll let me scroll here, there we go. So we're going to start by looking at, well, what is a perfect square binomial? And you can see they give you a couple of examples here, x plus 4 squared and x minus 5 squared. And if you actually look closely at the standard form of our equation, y is equal to a x minus p, fix that x, squared plus q, you can see that we have a perfect square binomial right there. So that is kind of key in converting that equation. So let's just explore a little bit of what a perfect square trinomial looks like. So in the first example here, they have x plus 4 squared, which we know is x plus 4 times x plus 4. And when we expand that, we get x squared plus 8x plus 16. We know that the middle term is the sum of these two numbers, 4 plus 4, and the last term is the product, 4 times 4. We can do the same thing with x plus 7 squared, so it's going to be x plus 7 times x plus 7, and so we know the first term will be x squared, the second term will be those two constants added, so 7 plus 7 is 14x, and then the last one is 49, 7 times 7. We then get some with negative signs, so the only difference now is, so it'll be x squared still. That's not a very good square. X squared. That's so awkward, this computer sometimes. X squared. Our middle term is going to change. So instead of being a positive, it's still going to be 5 plus 5, but it's going to be negative 5 plus negative 5, or negative 10x. And then our last term is always going to be positive, because when you multiply two negatives, you still get positive 25. So I'm not going to do the last example, but they've got a couple of general examples here. So x plus a squared is always going to be x squared plus 2a plus a squared, whatever a is, right? A is your constant or any kind of value. And x minus a squared, hopefully those kids aren't too distracting for you. Out of my control, unfortunately. And the school's closed today, so can't go up there to work. Doing our best here. So we got x squared minus 2a, not squared, sorry, that was an accident, minus 2a plus a squared. So a couple things to note, that last term is always added. Doesn't matter if that's a negative or a positive. It's always plus, because when you square a number, it's positive. And then the middle one is always just the sum of the constants, right? 2a. So we can go the opposite way now, just kind of getting used to these perfect square binomials. X squared plus 6x plus 9. So we're looking for two factors, or we're actually looking for the same number, right? We want to write this as one binomial squared. So we're looking for the one number that we can add together with itself to make positive 6 and multiply with itself to get 9. And so we know 3 plus 3 is positive 6, and 3 times 3 is 9. Same thing with 12 and 36. We know that x plus 6 will work because 6 plus 6 is 12 and 6 times 6 is 36. X squared minus 4x plus 4, so that negative sign tells me that it's going to be a negative in that binomial, or a negative sign here. And the two numbers that add to 4 and multiply to 4 are 2. Again, in the next one, because I have a negative b value or a negative constant in the middle there, or coefficient, sorry, it's going to be x minus, and then two numbers that add to 16 and multiply to 64, 8. 8 times 8 and 8 plus 8. Those are perfect square binomials. So now we're going to start thinking about, well, what constant do I have to add on the back end to make these perfect square trinomials? Well, two numbers that add to make 2 is 1, right? 1 plus 1. So then 1 times 1 will just be 1. And I know that's going to make it x plus 1 squared. Same thing with x squared plus 18x. So two numbers that add to get 18 are 9 plus 9. So 9 times 9 will go here, which is 81. And that becomes x plus 9 squared. In the bottom one, we're getting a little bit tricky here because we have 3, which doesn't cut in half. So we know that our strategy up in these ones where, well, what's two numbers that add to 2? 1 plus 1, that's pretty easy. And what's two numbers that add to 18? Well, 9 plus 9. But if we didn't know that right away, we could have said, well, 18, if we just divide that by 2, we'll get half of it, and then half plus half equals the whole, right? 9 plus 9 equals 18. Half of 18 is 9. So if we take that idea of cutting it in half, we can say, well, to get to -3, -3 is equal to negative 3/2 plus negative 3/2. Right? We don't know. That's 1.5, but we want to write that as a fraction. Excuse me. So what's 3/2? Negative 3/2, sorry, multiplied by negative 3/2. So that's going to give us that constant right there. That will be positive 9 over 4. So let's actually zoom this in because I think it'll be easier for me to write. So let's get rid of that. 9 over 4, and which means our constant here, our binomial, sorry, is going to be x minus 3/2 squared. We're going to do the same thing with this fraction. Things are a little bit weird with fractions, so don't freak out if this is a little bit weird. We're looking for two numbers that add to make a quarter, or a negative a quarter. So it's easier if you imagine negative 1/4 as negative 2/8. Because now if we're looking for two numbers that add to make negative 2/8, you could say, well, negative 1/8 plus negative 1/8. We can actually split that numerator a little bit easier. And now if we say, okay, well, if our constant here is that negative 1/8 multiplied by itself, or negative 1/8 squared, we're going to get 1 over 64. 1 over 64. So by adding that constant here, we're making this trinomial a perfect square trinomial, and we can split it into factors of x minus 1/8 squared. And the reason we can do that is because negative 1/8 plus negative 1/8 will get us there, and negative 1/8 times negative 1/8 will get us there. Perfect. So this, the process of adding a constant term to the end, what we were just doing in the last question, is called to make. So sorry, the process of adding a constant term to a quadratic expression to make it a perfect square is called completing the square. So there's like a little bit of a wordy definition here. So to complete the square of x squared plus bx, add 1/2 of the coefficient of x and then square it. So take that b value, take 1/2 of it, and then square it. And that's what we were doing up here, right? We took 1/2 of a quarter, and then we squared it to make 1/64. Same here, we took 1/2 of 18, which was 9, and then we squared it to get 81. So you get used to that process pretty quickly once I show you some real examples. So we're going to start by writing a trinomial in standard form by completing the square. So they actually have some really nice steps here for you. So the step 1 is to take the half of the numerical coefficient of the x term and square it, and then add and subtract the squared number in step 1. So you have to add and subtract, and I'll show you what I mean by that in the example. And then you form a perfect square, so you can write it in factored form. So I'll show you what I mean. We're going to start with, sorry for the kind of glitchiness of this computer right now. We're going to start with y is equal to x squared plus 10x plus 16. So let me write that down here. Y is equal to x squared plus 10x plus 16. And what we're going to do is we are going to write it in standard form. And what we're going to do is complete the square. So we keep our trinomial the same, x squared plus 10x, but I'm going to put that plus 16 over here. Still part of it. And now what I'm going to do is look at this binomial here, and I'm going to complete the square. So I'm going to take half of 10. We'll do that over here. 1/2 of 10, or 10 divided by 2, which is 5. And then we're going to take 5 squared, which is 25. That means the constant we have to add is got to be a positive 25 in order to make that a perfect square trinomial. So plus 25 gives us a perfect square trinomial. However, wait, I'm going to write that in a different color. However, we just can't go around adding 25 willy-nilly like this. That's mathemagic. So what you have to do is, if you're adding a 25, you have to subtract a 25 as well, because then plus 25 minus 25 equals 0. We're not adding anything extra to this trinomial, right? We're not just creating a 25 out of nowhere. We've actually countered it with a negative 25. And so now what you can do is turn this trinomial into a perfect square binomial, which is going to be x plus 5 squared, and then you're left with minus 25 plus 16, and you can simplify that bit right here, and you can say y is equal to x plus 5 squared, negative 25 plus 16 is negative 9. And once you've done that, you've got your equation in standard form. Seems like a long process. I'm over explaining it probably, just so that everybody gets a fair chance. I'll try to go quicker through the next one, and you'll see that it's not super complicated. It's just a little bit weird because we're adding and subtracting a random number out of nowhere. And I remember when I first learned this, I had trouble wrapping my head around it. But mathematically, if you add 25 and subtract 25, you're not really doing much. So it says here, a function f is defined by f of x is equal to x squared minus 9x minus 20. Determine the minimum value of f by writing the function in standard form. So the first thing we want to do is write this equation in standard form. In general form, it doesn't tell us enough information to find the minimum value. We need to find the vertex in order to find the minimum value. So we have y is equal to x squared minus 9x, but I'm going to put that minus 20 further down the road. Now I want to make this a perfect square trinomial. So what I'm going to do is do negative 9 over 2, take half of this value, and then I'm going to square it. Squared gives me 81 over 4, right? Because we'll have negative 9 over 2 multiplied by negative 9 over 2. Negative 9 times negative 9 is 81, and 2 times 2 is 4. So that means I have to add 81 over 4 and subtract 81 over 4. And now, here, we have a perfect square trinomial. We did that on purpose. So we can say y is going to be equal to x minus 9 over 2 squared. That 9 over 2 comes from here. Yay! And now we have minus 81 over 4 minus 20. So we need to write 20 as a fraction over 4 in order to combine those terms. So 20 over 1 is the same as 80 over 4. So we have to multiply the bottom by 4, and we have to multiply the top by 4. So I have y is equal to x minus 9 over 2 squared. And then I have minus 81 over 4 minus 80 over 4. And now that you have those fractions with common denominator, you can just combine them. So now we have, let me scroll up a little bit here. Y is equal to x minus 9 over 2 squared minus 161 over 4. There's your equation in standard form. A little bit messy, that one with the fractions, but not so bad. We know that this is our p-value and this is our q-value, and we know our vertex can be written as pq. So that means it's going to be 9 over 2, not a negative. 9 over 2 and negative 161 over 4. And we know that the y value of our vertex is our minimum or maximum point. It's a minimum point because it's a positive equation, which means it's a parabola going upwards, which means we have a minimum point. So we can say we have a minimum point at negative 161 over 4. Awesome. We're going to do this exact same process, but now we're going to do it with a little bit more complicated of a trinomial. So this time, I don't know why it keeps highlighting these pages. I just want to scroll. This time we're going to have a coefficient in front of our x squared term. So there's one more extra step to do. They're outlined really nicely here. I'm not going to read through it. I'm just going to show you an example. I think it'll be better, but refer back to this if you ever need a good step-by-step explanation. Once I scroll, if it'll ever let me. There we go. So now we have this equation. F of x is equal to 3x squared minus 18x plus 20. So we're going to convert that to standard form by completing the square. Then we're going to determine whether the graph of the function has a maximum or minimum value and find that value. So now what we have to do is, well, we have f of x is equal to 3x squared minus 18x plus 20. So what we're going to do is we're actually going to group these first two and pull out a common factor. This is the extra step you have to do. So you can see that we can pull a 3 out. So the idea is to be able to pull this whole constant out. Right? If you can't pull it out, then we're going to have to use other methods of factoring. And we're going to learn that in the next lesson. So that 3 comes out, and we're left with x squared minus 6x. And then we have plus 20. And now what we're going to do is look at what's left in the brackets, and we're going to try to create a perfect square trinomial. So f of x is equal to 3. Now I can say x squared minus 6x. So half of negative 6 is negative 3. And then negative 3 squared is 9. So I can say plus 9 minus 9 plus 20. It's important that you do when you do the plus 9, you do a minus 9 too. Otherwise, you're just adding 9 to the equation and it doesn't make any sense. Now we can rewrite this as 3. This turns into a perfect square binomial, which we know is going to be x minus 3 squared. And now we have to simplify minus 9 plus 20. Whoa, I missed a step. Sorry, rewind. I totally forgot about this. And this is already a long video. We actually have to put this negative 9 in those brackets. And then what happens when we pull it out of these brackets, we have to multiply it by the 3. That's what happens. Okie dokie. Since this 3 applies to everything in these brackets, every term, when we pull this negative 9 out of the brackets, it has to be multiplied by 3. So what happens is 3 x squared minus 6x plus 9. And now I've pulled that negative 9 out as negative 27 plus 20. There we go. I was doing some mathemagic there. Just because it's inside the brackets and it's being multiplied by 3. So if I pull it out, it has to be 3 times that value. Now what I can do is say 3, that trinomial becomes a perfect square binomial, x minus 3 squared, and negative 27 plus 20 is negative 7. And that's our equation. Sorry about missing that step. I totally forgot about it. So now we know our vertex is going to be PQ, which is positive 3, negative 7. And that means we have a positive value to positive A value means we're going to get a minimum. And it's going to be at negative 7, which is our Q value. Okay, let's do that process again. Hopefully it makes more sense. Convert y is equal to 7 plus 10x minus 2x squared to standard form by completing the square. In what direction does the parabola open? What are the coordinates of the vertex? So the first thing I'm going to do is rearrange this trinomial so it's in descending order. Negative 2x squared plus 10x plus 7. And then I'm going to factor the first 2 terms. I'm going to try to factor that A value out. So it's negative 2 x squared minus 5x plus 7. So now I know that 5 doesn't split nicely, negative 5. So I get negative 5 halves, and then I square that, and I've got 25 over 4. So I can write negative 2, complete that square, negative 5x plus 25 over 4 minus 25 over 4, all in brackets, plus 7. And then I can remove this term out of the brackets. And when I do, I have to multiply by that A value. So I get y is equal to negative 2 x squared minus 5x plus 25 over 4. And then this value is just negative 25 over 4. I'll do this over here. Negative 25 over 4 multiplied by negative 2 over 1 becomes 50 over 4, or 25 over 2. So now that becomes plus 25 over 2 plus 7. So I can rewrite that as y is equal to negative 2. That trinomial is x minus 5 over 2 squared. And 25, let's do this at the bottom here. 25 over 2 plus 7. Well, we need to write that 7 as a fraction over 2. We need a common denominator. So we have 25 over 2 plus 14 over 2. And that gives us 39 over 2. And that is our equation. So now we got to answer the question, in what direction does the parabola open? Well, we have a negative a value, which means it opens down this way. And then it says, what are the coordinates of the vertex? So the vertex is going to be our PQ, so 5/2 and 39 over 2. And that'll be right there. Fantastic. I know that was a longer video. It's a weird process. Try it a few times and you'll start to get used to it. Thanks for watching. Don't forget to like and subscribe.